we have big O notation. Um, it's a little less common than in the past, but in technical interviews, your interviewer might still ask you to give a big O analysis of what you just wrote. So, um, with that being said, what is big O? What did you get from the pre work, Ronald?
Um, I guess it's a way to measure like uh, space and time complexity, or like the basically how good your algorithm is.
Yeah, I like that.
Basically, for because it's to measure big data that's going to scale to like infinity or something like that, and so
Yeah.
I don't think that's a good explanation.
Anything to add to that, David?
Just that it measures how fast your algorithm runs, or should I say yeah, how fast it is.
Yeah, maybe. Maybe. Hara, anything to add?
Um, just alongside of what they said, so how an algorithm performs as the data increases.
Yeah, now we're getting somewhere. How an algorithm performs as the input size increases. Um, I think the way I like to think of it as kind of a way to roughly categorize the efficiency of your algorithm, but really just, function. Fancy way to say function. Um, by um, analyzing how the steps increase with um, with the increase in input size. And traditionally, when we say input size, we mean items in an array, size of an array. So why do we need this big O system? Why not just use um, why not just measure the amount of time an algorithm takes to run? So, like, if I wrote a function and I'm like, well, this function is really good, it's so quick. Why can't I just say, oh, it took 10 milliseconds? Isn't that like awesome?
It's different for every machine.
Yeah. So, every machine is different. We have like Chromebooks or like gaming laptops, or supercomputers. Um, yeah, so that doesn't tell us much. Also, what sample size am I basing that on? Maybe my algorithm runs incredible with 3 items, and then with 100,000, it's like a year, or just not usable. Um, so that's why simply just saying it took 10 milliseconds is totally meaningless. Um, so in Big O, it's not at all about uh, not the speed, really, uh, not the total time at all. And it's not the total number of steps. Really concerned with the rate of things increasing and not the things themselves. The yeah. As I increase the input, how does the additional time take? But not the total time. Like, we could have an algorithm that we label as like the best, like constant time, which we'll get into in a second, where it takes a infeasible amount of time to run, like a month or whatever. Um, but it would still be labeled the best. So it's not the total time. It's really just as your array gets bigger, how does that affect the time it takes? Questions on the high level of big O analysis? And then we'll start getting into the different categories. Okay, so what's the best? What's the best category? Ryan, what was the best category for big O?
Yeah, O1, I think it's constant, but it's basically immediate.
Yeah. So we call this constant time, right? I'm not sure I love you saying immediate, but we do call it constant time. And let's graph this out. Can I copy this? Boop. Boop. Okay, so what do we have here? We have we have input size. So traditionally our array, right? And there's a lot of things here. We could say like operations, but I think the easiest thing to think about is like the number of steps. So on constant time, this graph will just look like this. So let's say that this is like 1 second. We don't know. We don't even care. Or we can say like 5 seconds. The point is, if I have an array of 0 items, or I have an array of million, how many? I guess I'm saying 5 seconds in steps here. Let's say time, I guess. Yeah. So Jazz, how long will, if my array has 0 items, how long will this function take to fire?
5 seconds.
And if I have a million items, how long will it take?
A million.
Yes.
5 seconds. No.
No.
Oh, wait.
No. What'd you say?
Was it a million or?
No.
No,
So
okay,
it's always
sorry.
5 seconds. That's
Okay.
yeah. So no matter how big the input size, it's always 5 seconds time. And another function might be 10 milliseconds. And if I have 3 items, how long would this function take to run, Ketzerin?
It is still 10 milliseconds.
10 milliseconds. And if I have 1,000, how long would it take to run if it's constant time, Monica?
It would be the same 10 milliseconds.
Yeah, so even though we increased our array size by 10,000, the function just doesn't care because it's constant time. So, what's an example of constant time? Big O of 1. Can anyone think me of an example of a constant time function?
Accessing an element of an array.
Yeah, that's beautiful. So maybe we have an array coming in and we want the first item for whatever reason. To invoke this, I can do foo with 1, 2, 3. And am I running this code? No. All right, so we got the 1, but the main point is, I can even show this to you guys. So how long did this function take to run? Does anyone have a guess how long this function takes to run in JavaScript? And whatever you're thinking, it's less.
microsecond.
That's more than that, I think. Oh, maybe. So 0.37 milliseconds, which I guess is a microsecond, right? I don't know the conversion there. Let me define our array out here and then run this. So our array has 3 items, right? And it takes 0.1 milliseconds. What if I make another array and this one is, sorry, a million items, right? Can I do that? I forget. Let's see. Did I do this correctly? Let's console.log array too. Yeah. So it's empty of a million things, but it still is an array of a million things. All right, let's actually fill it. Dot fill. Yeah. We'll put in all zeros. Or did I do 0? Yeah. Okay. So this isn't like a perfect science using this console.time, but basically these are the same exact time. 3 items versus a million. So that's the idea of constant time. It just doesn't matter how long or how many things are in your array there. Cool. Any other examples of constant time that we can think of?
A hash function.
Yeah. So, yeah, can you give me an example or?
No, I'm just reciting what was in the video.
Okay. So what is a hash function, David, again?
It's a function that converts some input to another output based on a key value pair.
Yeah. Yeah, the problem is so I think you mean like hash lookup, because if we really had a hash function, it does have to iterate through every character. So I think that is going to be linear time, which we'll get to next. Yeah, but I'm not sure. I might be incorrect there. So let's leave that to the side for a second. Any other ideas of constant time? So what about something like this? What do we think about this? What's the big O analysis? And yeah, go ahead.
One constant time.
Yeah, but then the question is, well, we need a strategy of how to determine.
I think it's like 2 operations, right? One for creating, or I guess you could say one for creating the variable, and then one for assigning the variable.
Yeah.
And then 1 step for returning the variable. So
yeah.
that's 3 steps.
Yeah. So what I like to do is look at each line, and see if that line is dependent on the input size of the array. In this case, is this line dependent on the input size of the array?
No.
There's no input, so it can't be. So it's like 1 step. And this is 1 step. So even though we have 2 steps, it's not dependent on the input size, so we know it's constant time. Right? How about this? Actually, Whoops. The heck? Okay, while x is greater than 0, x equals x minus 1. First off, does this work? Foo3 array and actually let me do this. Array. We'll return the second item from the array at the end of the day. So we are using the input, but then there's some other stuff going on here. Oh, you know what? Actually, maybe we'll do this. Yeah. Okay. Does this work? First of all, let me console.log. Yeah. So 23 minus 0 is 23. Now, let's give it a big O analysis. So let's go line through line and see, is each line dependent or independent of the size of the array? So Catherine, line 26, how many steps is it? And do the number of steps change with the input size of the array?
Step 1.
Yeah, one step, and it has nothing to do with the size of the input of the array, right?
Yeah.
Okay. Monica, you have a more interesting part of this whole thing. So 27 through 29, that block, how many steps is it roughly?
Is it 999?
Yeah, roughly.
Uh-huh.
And is it dependent in any way on the input size of the array?
I don't think so.
Exactly, yeah. And then the return statement is how many steps, and is it dependent on the size of the array? Daniel?
I think it's one step. And I think you're just getting the index 1, so no?
Yeah.
I'm not sure.
Yep. So in total, this is, again, big O of 1. So that's all called constant time. Maybe we'll ask ChatGPT for David's example. Is a hash...
You're right. It's a hash lookup.
Yeah, that's what I thought. Okay, is a hash, or generate a hash lookup function and categorize its big O notation. So we'll let that work. This is more than I bargained for. Okay, so on average, they say it's 01, which makes sense. Because that hash lookup, you're taking like a string and converting it to a number. But it should... does it matter? Yeah, I think it does matter on the size of the string. Or maybe it's I don't know. I'll have to think about this more and maybe get back to you guys at the end of class. Okay. Yeah, I'll have to think about that more. Anyway, so that's constant time. We move on to what we call O of n, which is linear time. And can anyone explain to me what the graph for linear time is going to look like when we have time and input size? So as input size increase,
It's going to be a slope.
yeah, it's going to have a positive constant slope. So what this is saying is, well, here we can't have 10 milliseconds anymore. It doesn't make sense. Here, as the input grows, the time does grow. But we're not saying at what rate it grows. We are saying at what rate it grows. We're saying it grows at a constant rate, which is important. Because
would that be like 1-to-1 kind of like?
No, because right here the slope is 1, but I want to show you another example that's also constant time, where you could have the slope pretty extreme, and then another one where the slope is pretty small. But these are all linear time functions. So when the size of the array increases, it does increase, and it increases at a constant rate. But the rate that it is increasing, I think this is called m in math, right? The slope. This might be 1, the rate that it's increasing. This might be, I don't know. Someone better at math can correct me. This might be a quarter, right? So this is the slope of the line. So they all are increasing time with increasing size, but at a different constant rate. All right, so who can give me an example of a big O of n function? Big O of n. This is more interesting because now the input does matter.
Looping through an array?
Yeah, for sure. Looping through an array. So maybe we have an array and we have an item we're looking for. And we want this function to see if the item is in our array. Maybe I should use normal, or you guys. For of loops is going to be the same as a traditional for loop.
Yeah, IO, whatever containers. Or
So,
like a method, built-in method.
So here, what am I doing? If item equals item. Okay, so we're iterating through this array. We're checking each item, and if the item exists, we're returning true. And if not, we're returning false. So who can help me invoke this function with some proper stuff? Renata? To test this.
I don't know.
Okay. Victor, any ideas how to invoke this function with an array and the item we're looking for? How do I invoke any function?
Yeah, I'm drawing a blank right now. Sorry.
No worries. So foo
calling
for, yeah. And then give me just any array of numbers.
5, 10, 15, 20.
Okay. And then the number we're looking for, we'll say, is 3. So what do we expect to see in the console.log here, Renata? We can take it line by line too.
Edit.
And let me change this. Let's say we're searching specifically for numbers.
Item array, find item equal.
Any guess?
20.
20? Let's take it line by line, right? For
False.
let underscore num of array. So the first iteration, underscore num is going to be equal to 5. Is underscore 5 triple equal to 3? No. So we go to the next iteration. Is it 3 equal to 10? No. 15 equal to 3? No. 20 equal to 3? No. So finally, line 46, we return false, right? Yeah. But now if we do 5, we return true. So let's do a big O analysis of each line. So how many steps is this first line, and is it dependent on the size of the array? In other words, if the size of the array changes, do the steps change? Alex, any ideas? So how many steps roughly is this line 41 if it's invoked with the arguments we're invoking it with? And do the number of steps change if the array gets bigger?
I'm not sure.
Okay, opens to the class.
I think with the given array and item, it would only be one step, and it wouldn't really, since you're finding it the first time, I think.
Okay, that brings up a good question. Well, what if we get lucky and hit the number the first time? So in big O analysis, we only consider worst case. Yeah, so we're always assuming that whatever function we write is like we're the most unlucky we can possibly be for big O analysis.
So then 4 and yes.
Yeah, so 4 steps and yes, more steps with more array items. Yep. How about this? How about this? Lines 44 through 46. So this is where things start to get a little confusing. But what do you think? Kimberly, any ideas? To compare two things, how many steps is that?
To compare two things, I would think would be one step at a time.
Yeah, just one step. And returning true, how many steps?
1. 4.
No, just one step. Yeah. These two lines themselves. We're not really considering what's going on outside of these two lines, which is the confusing part. But these two lines independently, do they change with an increased number of items in the array? Just these two lines?
No.
Yeah, no, they're independent. And then line 48, how many steps, and is it dependent on the size of the array? Roman.
Yes.
So if I increase this array by 1,000,000, somehow returning false is more steps?
Oh, no.
Yeah, just one step. So we take the worst case here and we see that line 43, yes, there's more steps with more items in the array. But what's the increase? So for every additional item, in array, how many more steps do we have to do of line 43? We have to do like n more steps, kind of like one more step. So there's a linear relationship. So this is why this is a big O linear time. If you add one number to the array, that's one more like iteration of the loop we have to do, one more step. Questions on linear time. This is, if you're iterating through anything, you pretty much know your linear time.
I have a question about 44 to 46. if you get the number the first time, I get that it's 1. But if it has to keep checking, wouldn't that increase?
No,
the
no,
step?
return. What does return do in a function?
Not the return part, but the line 44 specifically.
What? So what about this? One more time.
Because it's checking if the number is exactly equal to the other number, correct?
Yes.
So if we're looking for 15, it would have to check it 3 times. No?
Yes. This will run. This line will run multiple times, but we're considering. We're including that extra runtime in this line instead. Is how we're thinking about it. But I do know that's weird. Okay. Because really this line itself will run 4 times in the worst case. Yeah. Which I know is not very satisfying, but this is kind of the game of Big O. It kind of boils down to a simple idea. If your function has a for loop and that for loop is in any way dependent on the size of the array, then you have linear time kind of deal. But it can get a little tricky sometimes. Let me try to trick you guys. So foo5, give me a big O analysis of foo5. It's still going. Jiang, what do you think?
Foo5. So I think like because you get 5 times 5 high in the console log, so that means like they will run 5 steps.
Sorry. Lines function foo5.
Sorry. Okay. Yeah. It will run 10,000. Yeah. Times.
So 10,000 steps. So
Yeah.
that's awful. That sounds like so much, right? So it's got to be like something bad, Big O, or what?
But because it's still linear.
Not linear.
Really?
So is this line dependent on the size of the array of input? It's kind of easy because there's no input, right? So it's not dependent on anything. It's just constant time. So even though we have this for loop, it's not dependent on the array size. We're not doing like array.length. It's just a set number.
Okay. Doesn't
matter how obnoxious that set number is. It's still just a constant number of steps. So that's linear. That's constant. That's linear time. Any questions on that? Because it gets worse going on. All right. So next up, we have quadratic time.
I have a question.
Sure.
So line 56 from like I less more than 100, so it's mean gonna be only 100 step, right? Because it's like involved with the 100. Before you put like 10,000 and then they going to be 10,000 steps, and now you put 100, it's gonna be 100 steps.
Yeah.
Okay. All right. Good. Thank you.
Yep. Okay, quadratic time. So what does that look like with our graph here? So any ideas what quadratic time is going to look like? As input grows, does time grow? And if so, how does it grow? Does it grow at a constant time? Does it not grow at all? Does it decrease? What do we think for quadratic?
Increase 2 times.
Yeah, it's going to increase. And it's not just going to increase linearly. It's going to increase quadratically. Do we have any math people here? Strong math background? Actually, I could use clarification on what that means. I know it means it increases more than linearly. So I think the slope. So right here in linear time, our increase was constant and we had a constant slope. But here, maybe our slope is 1 right here on this point. But then here it's going to be like 10. So not only is it increasing, but it's increasing at an increasing rate. So we have like acceleration. So we have quadratic growth. But I'm sure I'm butchering the math of this because I don't have a strong math background. So let's look for an example of quadratic time. Can anyone think of one? You teased me, Hara. You just did your mic like you're going to talk and then...
No, because I did see an example, but I don't know
okay.
how I would explain it. That's why.
I think I got one.
But it's like if you're...
No, where is it?
It's taking double the amount of time. So it's like if you're nesting.
Yeah, in the interest of time, I'm not going to write this out. But here I got one from ChatGPT. So what if we wanted to remove duplicates from an array? And let's test that this works because I haven't even looked at it yet. So we have an array of 1, 2, 3. 3. And we want to remove the duplicates using their function. And it worked. We have 1, 2, 3. Very nice. So let's try to look at the logic of this, right? We're creating a new array. We're iterating through our arguments array's length. So right away, we know we're not constant time because we're dependent on the size of this array for the number of steps. We have a flag here of is duplicate, false. And then we're iterating j is less than unique array dot length. This might be a problem. J equals 0. This array length is 0, right? So this isn't going to run? Oh, okay, got it. Okay, so the first iteration, this isn't going to run. We can ignore that. And then if not is duplicate, so we're banging this flag, so we're making it true. So in unique array push, we're adding the first item to. Okay, second iteration, I is 1. J is 0 again, right? Yeah. Array bracket I, so that's our original array. We're at the number 2 now. Okay, is 2 equal to unique array at 0? No. So that's false. And now we check all the other numbers, but that was the only number to check. So we break out of we're done with this loop. And now we go to if not is duplicate, we're still good. So we're pushing now the 2. Anyway, you can look at this logic. You'll have this code. I think it makes sense to me, but Let's give a big O analysis now of this function. So, line 63, how many steps and is it dependent on the size of the array? Rodrigo, how many steps is declaring a variable?
Is it one?
Yeah, one step. And does it change based on the array?
No.
No. Okay. Line 65, Ronald. How many steps in our example, and is it dependent on the array?
It's gonna take, I guess, n steps.
Yeah. Perfectly said.
So
n right here is 4, but if n was 1,000,000, it'd be now 1,000,000 steps. So we have n steps. This is one step, but then here again is how many steps?
I believe that's also array dot length. I feel like it's gonna be n steps because that's gonna be
Yeah, I agree.
Grow.
I mean, it might be, so here's the thing. It might be like n minus 5 steps if we get lucky or who knows.
Yeah.
But we're always worst case. So we're dropping those things we might get lucky with.
Right.
But here's,
right.
But now we have the situation, we have n steps for every n step. So we have to multiply these. So together they become n squared. So now we know this is big O of n squared. Whoops. Okay, this is kind of an oversimplified real introduction to the idea of this. We haven't talked about log n log n, factorial n. There's a million of these, right? These are like the most common ones. Yeah, so this is a kind of just a broad introduction, a simple introduction. But the overall idea is the most important. So Big O is this rough tool to categorize the algorithms we write, which is just our functions, our code, how efficient they are as we increase the size of the input. Questions on this? Okay, so mock technicals today will be very similar to this. So try to challenge yourself to think about some constant time functions, linear functions, and quadratic functions. Have that in your mind, okay? Some examples. And then you'll do good for the tech interview. Okay, I think that's it for lecture. Any final questions?
I have a question. So did you say that it's kind of like I guess this type of interview, these questions are kind of like fading away?
Yeah.
Or like kind of being transitioned out?
Yeah, I think so. So in the past, I mean, before my time, so I'm speaking somewhat out of pocket, but the tale around the table is that this used to be like the gold standard. This Big O analysis, along with like, all the data structures, which we'll talk about, linked list, trees, graph, binary search trees, used to be like the real standard of every tech interview, and that's totally gone away. I've never been asked. Well, the biggest companies I've interviewed at are Amazon, Expedia. Never was asked like one of those kind of old school data structure and algorithm questions. But with that being said, you still absolutely could be asked it. And it is very impressive at the end of your mock technical interview to offer, don't just dive into this, but, oh, would you like me to give the big O analysis of what I wrote and possibly talk about how, if I had more time, it could be better or more efficient. Very impressive.
I guess then if you were to say, like, if you were to get interview like now,
Yeah.
would you say that like if you could categorize like 3 different things, like let's say project review or like algorithm or like I guess general domain knowledge, like the theory, like just like JavaScript knowledge, like questions and stuff about like you know, like functions and all that kind of stuff. Which would you say is like in the order of we should kind of like focus on? I guess. I mean,
Number one is JavaScript basics. So like you might get something as easy as like find me the biggest number in an array. Like you literally could get that as your tech interview. So like the basics are the most important. Second, I would say React. You'll probably get something like make me a form in React. I got hired at Petco and they need a form to find a new dog, or just like the most basic React components you could build. Honestly, the questions are not crazy. Like if you go in there and they're like, do a depth first search on this, you know, whatever, like it's just, that's like what YouTube videos like to talk about, but that's not like actuality. Like usually it's just like so simple.
I see. And what about classes and stuff? Do they ask like very vanilla JavaScript stuff? Because, you know, like I know.
You could absolutely get something like we got yesterday. Yeah, you could.
Okay.
And you could well, you could say, hey, look, I use modern React. It's all functional components. I haven't used classes. And that sounds reasonable. And maybe they'll even let you use a function instead, like a function that returns an object or something. With that being said, you should be able to write a basic class. All right. Let's get you into your rooms. Stop recording.